universal force of gravity, and then we will move to the gravitational field strength for today. Okay, so it's said that if two objects have masses, then they experience a force that is known as the universal force of gravity. So as soon as the object has two masses, mass 1 and mass 2, then those two objects are experiencing a universal force of gravity, which is always attraction. So force object 1 is experiencing a force that is attracted to the object 2, to the center of object 2. So this is the universal force of gravity that object 1 is experiencing as a result of the presence of object 2. And this is the force of gravity that object 2 is experiencing as a result of the presence of object 1. We have said it even before when we talked about action-reaction force, or the third law of Newton, that in magnitude, those two forces are equal to each other in magnitude. But in the direction, they are opposite. So those two forces follow the relationship that they are opposite forces, but they do not cancel each other because they are experienced in two different objects. And you had a question like this in the quiz, majority of on the test, and majority of you got this question. So, however, like this is based on the third law of Newton, that the two forces are equal in magnitude and opposite direction. However, what is this force? It has been a study that mostly Newton had, and what he figured out is that the force of gravity is in direct proportion to the product of the two masses. Now let's talk a bit about this sign here. So this means is a direct proportion. Direct proportion means that at the same factor that you are increasing one of the, or in this case, one of the terms here, or decreasing one of the terms, at the same factor will increase the force. What do I mean by this? Let's suppose that I will bring this relationship again. So force of gravity is equal to, or is direct proportional to, the product of mass 1 and mass 2. So if I'm increasing mass 1 by a factor of 2, then force of gravity will be increased by the same factor of 2. What does that mean? So if mass 1, the new mass 1, is becoming double the mass 1 old or original, then force of gravity new will be become 2 times force of gravity original. And on the other hand, if we are decreasing either mass 1 or mass 2, doesn't really matter, by a factor of 3, then by the same factor will be decreased the force of gravity. So if you are making mass 2 1/3 of the original mass 2, then force of gravity that those two objects are experiencing now will be decreased by a factor of 3. So will be 1/3 of the original mass. On the other hand, what was noticed was that the force of gravity was direct proportion force of gravity was direct proportion of the inverse square of the distance. So see what we have here. It's 1 over d squared, where d is the distance between the two centers of the object. So if we have object 1 here and object 2 here, the center of the object is this one and this one. And then the distance, or the distance that we are talking on this case, is the distance from center to center. And force of gravity is the inverse squared of the distance between the two. Now, if you go to your calculator and you enter something like this, any number, 4 over x squared, and then you graph it only on the positive axis, then you will see a graph that looks like this. Go to your calculator and try it out. Okay, so now in our case, what we will see, because here we have x and y as the axis, in our case, what we will see will be something like this. Force of gravity is here, and the distance between the two centers of the object is in the horizontal axis, and as the graph, you will see something like this. So when you see this graph, what does that mean? Is that the vertical axis and the horizontal axis are asymptotes. I don't know if you know the terms of asymptotes, but just in case, if some of you do not know, means that it's a line that the graph approaches infinitely without touching it. So the red graph that we have here approaches both horizontal and vertical axis infinitely. It doesn't matter how long you are going to, for how long you are going to, or how close you are going to. It approaches infinitely without touching it, without touching the horizontal nor the vertical axis. However, in physics, we do not work with a graph that has a shape but just the straight graph. So we don't prefer to have a graph that is a curve or a quadratic or so on. What do we prefer in physics is a graph that is a straight line. Now, I want you to think about it and tell me, what should I modify, either the horizontal axis or the vertical axis, to make this graph, so force of gravity is direct proportional 1 over d squared, into a straight graph. Okay, when we are trying to straighten a graph to make it a straight line, what we are doing is we have our equation. In this case is a relationship, not just an equation. We are mirroring it with y equal mx. So the x in our case will be whatever is happening to that is known as the manipulated variable, because what is happening here is we have two variables, like in every experiment that we do in physics. We have a manipulated variable that is, what are you changing? And we have the responding variable, which is, what are you measuring as an effect? What was that? As an effect of the change that you are doing. Okay, so now on this case, and actually in every case, the manipulated variable is represented by the x or the horizontal. and the responding variable is represented by y, or the vertical axis. Okay, so now when we are always keep this as the guide for you to straighten the line, because it doesn't matter what is the equation. The equations may be endless. However, when you see them, you have to think, okay, what is happening to the manipulated variable, which is what you are changing, and on this case is the distance, because it is on the right side of the equation. So this will be the clue. It is squared up and then it is inversed. Therefore, your new axis, your new manipulated horizontal axis will reflect this mathematical manipulation. So what you have to do in order to straighten a graph will be making the horizontal axis as 1 over d squared. So if we have an equation that is force of gravity is direct proportion of the inverse square, in order to straighten it out, we have to make the horizontal axis as 1 over d squared. So let's stick a bit with the fact that universal force of gravity is equal to, or is direct proportion, not equal, is direct proportion to inverse square of the distance between the centers of the objects. So now, what do you think that will happen if I am increasing d by a factor of 2? What do you think that will happen with force of gravity on the chat? So on the chat was said that it gets smaller by a factor of 4. Why by a factor of 4? Because 2 is increased, so it's increasing by a factor of 4. By a factor of 2 means that 2 to the power of 2 is 4. Therefore, what 1 over 4 will be what it is increased the force of gravity. So it is 1 over 4 decreasing, not increasing. The force of gravity is decreased by a factor of 4, or it's changed by a factor of 1 over 4. So now, again, since force of gravity is direct proportion of 1 over d squared, and what we are doing is we are decreasing d by a factor of 3. What do you think that will happen to the force of gravity on this case? It is increasing by a factor of 9, because what is happening here is 3 to the power of 2 is 9, and then will be 1 over 3 to the power of 2, which is 1 over 9, which is 1 times 9 over 1, or equal 9. So now what was figured out is that the universal force of gravity is direct proportion of the inverse squared of the distance between the two centers of the object, and the universal force of gravity is direct proportion of the product of the masses of the two objects. When you put those two together and make them in an equation, what will you see is that universal force of gravity is universal constant, capital G, mass 1, mass 2 over distance squared. in your formula sheet, this formula is as capital G mass 1 mass 2 over r squared. In this formula, the universal force of gravity is a constant, which is 6.67 times 10 to the power of negative 11 newtons meter squared per kilogram squared. Mass M1 is mass of object 1. M2 is mass of object 2. And D or R, it's the same thing. D or R is the distance between the centers of the two objects in meters. So mass is in kilograms. And distance between two centers of the object. It is important to say it's between two centers because we are dealing now with large objects like Earth or Sun, and the distance from the surface to the surface is different from the distance from the center to the center. And what we are talking here, what this R represent or this D represent, is the distance from center to center. Center of the first object to center of the second object. And it is measured in meters. Okay, so so the first example is, what is the gravitational force of attraction between a tanker with a mass of 50,000 kilograms and a super tanker with a mass of 150,000 kilograms when they are separated at a distance of 500 meters? So what we do is sort what is given, like in everything. But there is a question, we go mass 1 is equal to 50,000 kilograms, mass 2 is equal to 150,000 kilograms. It's important that they are in kilogram and meters. The distance, you can say D or R is the same thing, it doesn't really matter. What is important is just to be in meters, and what they are asking you for is the force of gravity that they are experiencing. Keep in mind, force of gravity, it's always an attraction force between the two objects. And the assumption that we are doing here is that the distance, 500 meters, is from the center to the center of the tanker and the super tanker. So now, the universal force of gravity is calculated as uppercase G, which is the universal, universal constant universal of gravity, M1, M2 over R squared. So 6.67 times 10 to the power of negative 11. And let's write the units here because you will see that they will work out to be cancelled. Times 5,000 kilograms times 150,000 kilograms over 500 meters squared. Okay, so this is the second example. Now what we see is two dense objects with masses 5.0 times 10 to the power of 8 and 6.0 to the 6.0 times 10 to the power of 8. If the force of attraction between them is 500 newtons, so what is the distance between their centers of the masses? So what is given here is that mass 1 is 5.0 times 10 to the power of 8 kilogram. Mass 2 is 6.0 times 10 to the power of 8 kilogram. And the force between them, the universal force of gravity, is 500 newtons. And what they are asking for is the distance, or the d or r, the distance between the two centers. If you are going to picture what is happening, is that you have two objects, object 1 and object 2. The force of gravity that they are experiencing is this one and this one, and they are equal in magnitude of 500 newtons. Gravity 2 is experiencing as a result of 1 is equal to 500 newtons. And what they are asking for is the distance between the two centers. So is this one here. Now you can work in two ways on those kind of questions. My suggestion and my preference is to work with the formula and manipulate what they are asking for. So what I will do, if I was your age, I will write the formula and then think, how can I make it, manipulate it so that I solve for D? So in this case, what I will do is I will divide both sides by G, M1, M2. So force of gravity, G, M1, M2 is equal to 1 over D squared. You can even go multiply, cross multiply the two, and then so then D squared will be G M1 M2 over FG. And then in order to find D, because we are still not done, we have D squared here, not D. Then we square root both sides. So D will be square root of G M1 M2 over FG. However, if you find that this is difficult, then what do I suggest you doing is substitute what was given. So you had on the first case is the force is 500, and now we are not writing units here because we dealt with units, the units work, and this is, we are just writing numbers here. 6.67 times 10 to the power of negative 11. The first mass was 5.0, if I'm not wrong, 5.0 times 10 to the power of 8. And then the other one is 6.0 times 10 to the power of 8. So we write those two masses here. 5.0 times 10 to the power of 8 times 6.0 times 10 to the power of 8 over D squared. So in your calculator, D will be equals to, figure it out what it is and tell me in the distance is 200 meters. Does this make sense? So even when we read this question, and if we connect with what we did in the previous part of this unit. So now 100 kilogram has a weight of 981 newtons. Why is it like this? Because we said that force of gravity is mass times acceleration due to gravity at the surface of the Earth. Actually, at any point, but we are talking here the surface of the Earth. So if we have 100 times 9.81, that is the acceleration due to gravity at the surface of the Earth, this will be 981 newtons. So mass, 100 kilogram, is different from weight, that is a vector. What is person's weight at a height of 12,000 meters above the surface of the Earth? Now, I have here even a note saying what is the radius of the Earth and the mass of the Earth. But if we are drawing a situational diagram, then this will be Earth. And here is the center of the Earth. And from the surface, a person is standing here. How is it standing? Don't ask me. So now, the distance between the surface and where the person is standing is 12,000 meters. However, as I said, we have to take into the consideration the distance or the radius of the object. So because the distance is from the center to the center, and the mass of the person that is standing 12,000 meters away from the surface of the Earth, and the center of this person is 1. The point where is it standing, and the center of the mass of this person is at the same point. We can assume that it's. However, in order to calculate the D for our formula, force of gravity equals to universal constant m1, m2 over d squared. This d is taking into the consideration the radius of the Earth and the distance from the surface to the person. Does this make sense? So now, from the data booklet, you can figure out that the mass of the Earth is at the constant part of your data booklet is 5.89 times 10 to the power 24 kilograms, and the radius, so this one here, of the Earth is 6.37 times 10 to the power of 6 meters. So now what we have is that mass 1, which is mass of the object, is 100 kilogram. Mass 2, which is the mass of the Earth, is equal to 5.89 times 10 to the power of 24 kilograms. The distance between the center of the Earth and the object, the person that is standing 12,000 meters apart, will be 6.37 times 10 to the power of 6 plus 12,000 meters. And what we are looking for is what is the force of gravity or the weight that the person is experiencing at that point. Okay, go ahead and complete using this formula in your calculator and tell me what. Okay, so the force of gravity or the weight that the person is experiencing when he or she is 12,000 meters away from the surface of the Earth is 979.3, but it's fine to say 979 newtons, which means that if you want to lose weight, notice here what I'm saying, lose weight, go in the space, go away from Earth, because mass is a scalar quantity, doesn't change. It doesn't matter where you are at the surface of the Earth, at the surface of the moon, at a distance away from the surface of the Earth, the mass is still 100 kilograms, but the weight changes depend on where you are at. If you are at the surface of the Earth, then your weight will be of a person that is 100 kilogram will be 981. But when you are 12,000 away from the surface of the Earth, then your weight will appear to be 979, less than 981. And if you are at the surface of the moon, which has a gravity 1/6 of the gravity of the Earth, your weight will be 163 or 64 newtons. Does this make sense? So the attraction force is 9.0 times 10 to the power of -6 newtons. The distance between the two objects is 50 meters. Now, what is the mass of each object? If, so this is the part that we have to look carefully. If one mass is 3 times more massive than the other. So if we are saying that mass 1 is mass 1, then mass 2 will be 3 times mass 1. Now we are finding what is mass 1 and what is mass 2. Okay, this expression here, 3 times more than the other, is translated into, we are saying mass 1 is mass 1, and mass 2, object 2, is 3 times more massive than the other mass. So now what we have is universal force of gravity is capital G mass 1 mass 2 over r squared. Or universal force of gravity is capital G mass 1, which is mass 1, 3 times mass 1 for mass 2 over r squared. And now mass 1 times mass 1 will be mass 1 squared. So capital G 3 times mass 1 squared over r squared. From here, we find what is mass 1. Go ahead and do it in your. So from the calculation, from the calculations, we find that mass 1 is 1.06 times 10 to the power of 4 kilograms. And then mass 2 being 3 times more massive than mass 1 will be 3 times 1.06 times 10 to the power of 4 kilogram, which is equals to part of 3.18 times 10 to the power of 4 kilograms. Do you have this answer? When two masses are set at a certain distance apart, a force of 8 newtons exists. Attraction force, a universal gravitational force. What is the force? So now what is the force between two masses if the distance between them is doubled and one of the masses is tripled? So we don't know what is mass, we don't know what is the distance, but what do we know is that on the first situation, I will say it, original situation, what do we have? We have a mass 1, a mass 2, and a distance, original. These are all original. And then, as a result of this setup, what do we have is the force of gravity, original, is 8.0 newtons. Now, in the new setup, what we have is one of the masses is triple. I will say mass 1. You can say mass 2. Doesn't really matter. So one of the masses is triple. So mass 1 new will be 3 times mass 1 original. Okay? Since we dealt with this case that one of the masses is triple, then mass 2 will be the same as whatever was on the original situation. But the distance between two masses is doubled. So distance nu will be 2 times the original distance. And now we are asking, what is the new force of gravity that the object is experiencing? I want you to try it on your own, and then I will go over. If we write based on the relationship that we know, that the force of gravity is capital G, mass 1, mass 2 over d squared, we can say that for the original situation, the force of gravity can be written like this. Capital G, mass 1 original, mass 2 original over d squared original. And for the new situation, force of gravity will be capital G, which is the same in any situation. Mass 2 nu, or mass 1 nu first, then mass 2. Mass 1 nu, mass 2 nu over distance nu squared. However, on the new situation, what is happening? Some of the quantities are changing. So the force of gravity nu will be capital G, which doesn't change. Mass 1 is becoming 3 times greater than the original one. So this will be the same as saying 3 times mass 1 original. Okay? Mass 2 is not changing. Mass 2 is the same as mass 2 original. So mass 2 original over distance is changing as well. Is becoming 2 times the original distance. And this, the whole thing is squared up. Is this clear what I did? So now what I will do is I will expand this square here first. So this is affecting, the square is affecting 2 and distance. So this will be the same as saying G times, or 3 mass 1 original times mass 2 original over 4 distance original squared. Is this clear? However, if we compare now this relationship here with the relationship that we have here, then we can say that G M1 M2 D original squared, this whole expression here, is the same as saying the original force of gravity. And what is left, so force of gravity nu, now it's becoming the same as 3 over 4. This is what is left, 3/4, and the rest of the expression is the same as the force of gravity original, this one here, which was given in our question to be 8 newtons. So this will be 3/4 times 8 newtons, which means that the new force of gravity will be equals to 6 newtons. Does this make sense?